right, I think we're live. Give me just one sec. Okay. Welcome back. We're gonna pick up where we left off last time. We've still got some motor mounts to prepare, but we're gonna start with. Just realized this is like right in the way of the camera. That's kind of dumb. But we're going to get the. I know we did the Y rod or the Y carrier last time with the bearings, but we're actually going to start with preparing the alternative to that, which uses the 16 tooth idlers. Chip, I'm glad you're here because I might need some advice. The 16 teeth idlers I didn't see in the CAD. So let's walk through this. So yeah, last time this is what we made. We used the belt method to put the bearing and the washer stacked together and then pushed it into place, screwed it down after some trial and tribulation grabbing the wrong screw, but that's not a problem. I want to use the 16 tooth idlers. I think there were some questions on whether they'd last as long, but I do like running the belted or the toothed part of the belt over a toothed idler. It just makes sense to me. So we're gonna start with that. Hey, Coldsaur. Good to see you, dude. How you doing today? Well, this got super laggy as soon as I opened it up. So that's the motor mount. We're looking at the Y carrier. Dominic, welcome back. Good to see you. So Chip, I don't know, is this in the step file or is it like a separate, is the tooth idler in a separate Fusion, or not Fusion, a FreeCAD file? If it is, I can actually open that up. I've been trying out Onsel, which is, I won't call it fork, but it's another kind of flavor of FreeCAD. And I've been liking it a lot more than the base version. I've actually used it for a couple of different things. But I have the main assembly open here. Let me see if I can find the toothed, or the different variation of that Y carrier really quick. Yeah, looks like we got it right here. Okay, no spacer? That was going to be my question. Yeah, it's not in this, but I think, if we were to measure that, that would come out about right. Side note, when you print these in the documentation, Chip has a recommendation to put some small supports on the inside in here. I went overkill on one of the prints. Actually, the ones that we did in the last stream, I printed these without any supports and they still came out okay, just required a little bit of cleanup in the slot. These ones, kind of the same thing. Even after removing the supports, it's still a little messy in there. I don't know if you can tell very well. But we'll see what we can do to make sure that's nice and clean. So the tooth idlers, let's go ahead and find those. There we go. Yeah, those should fit in nice and easy without too much hassle. If we're going by our Measurements from last time for free or fusion. If you were here on the last stream, you know that I was trying to use the wrong size screws for this for like, I don't know, 15 minutes. Made a fool of myself, so we're going to make sure we use the right ones this time. And I'm not sure if I've got those out right now. M5 by 20, but I think we need M3 by 20. We also might have run out. So yeah, I've got one left here. So I'm just going to grab my kit really quick. Oh no, it's right here. I've got M3 by 20s here we can use as well. Perfect. Might need the belt method on this one too, Chip says. So we'll see what happens. Also, when I was painting on supports with this, I ended up getting some support material right in there where the pulley's going to sit. So hopefully that's not going to mess things up, but we'll see. It's just kind of on the inside pocket there, right underneath where the screw goes in. Shouldn't be a big deal though. So even though you might need the belt method for this, Chip says, it's going to be a lot easier because if you drop it or if it gets out of whack, it's not going to, the whole stack's not going to fall apart with the bearings and everything. So that should make it a little bit easier to work with. And yeah, even though we can get this without the belt method, it'll be easier to hold it in place with it. Again, if you've got your piece of spare belt, just take it, wrap it around like so, and then you have a little more control over it as you try to get it into position. You also can, we found out in the last time, it's a little bit, it's possible to be able to put it into position and make the hole line up. I don't know if you're going to be able to see. I did order a better camera today, guys, so hopefully I'll have some better quality in the next stream. And you can actually use a set of tweezers or another small hex key to help line it up and get it centered. Just realizing this, I keep changing my mind on which direction I want this. Oops. One where I want this to sit. Right now, it looks like I need more real estate on the left side of the screen, so we'll put it over there. So once that's in place, as long as you hold it kind of level, it shouldn't go anywhere, and we can get our screw into place. Chip, I posted about this in the Discord channel earlier, but I found out about Onsel today, the CAD program that's based on FreeCAD. Curious if you've used it at all, or what your thoughts are on it. You're the leading FreeCAD expert in the open source community, I believe. So curious if you've given it a shot and if you have any thoughts on it. It's totally free and open source, just like FreeCAD. The only paid options that are available are online like collaboration features where you can upload your CAD models and collaborate with others. Kind of like, I mean, that's one of Fusion 360's features. But I've been trying to look for an excuse to get off of Fusion 360 for a while. I'd like to be able to use it without the limitations they put in place on licensing and profit. But I haven't found anything that really does what I need it to for a guy like me that struggles to learn the ins and outs of the FreeCAD system. But Onsel has a lot of features that are directly, like you can very much tell they're trying to make it as much like Fusion as possible. And I think they've done a pretty good job. I'm pretty happy with it. The fact that it's still free and open source and you only pay for, you know, if you want to use the collaboration feature, which, you know, FreeCAD proper doesn't have any real solution for that right now. But it can open FreeCAD files directly, and when you save a file, it saves it in the FreeCAD format, so there's no proprietary file format either, which I think is really neat. Oh, we only need it on the front slot. So you're saying down here? Oops. So with this, we shouldn't need the belt method then, right? So yeah, thinking about the belt path, if our smooth belt goes in the back here, then that's what Chip's talking about. So when you say the front slot, Chip, are you talking about the one that's closer like this? I imagine you mean so we don't need it in the back one that I did the first time, right? Now this is where it's kind of hitting that support material. So you might have to turn a little more by hand if you run into the same issue. When doing that, I prefer to use proper hex key. Okay, so we still need the bearing stack for the back is what it sounds like. So we'll do that. Oh wait, this is going in all crooked like. What are we doing? That support material might be messing things up more than I realized. Dropped that thing like 3 times now. Yeah, it looks like unfortunately this one has too much support material. Let me grab my tweezers. Right down here in this hole. And so I don't know if I'm going to be able to get it out, to be honest, without drilling out the hole too much. So we might just move forward with this stack. No, not that. With this stack for now. Take out this front part. I was hoping to have like both available just to show both completed. But we're just going to take this front stack, or the back. I'm getting mixed up now. Yeah, so we'll take the front out and then put the tooth idler in and we'll move on from there. I might be able to drill that other one out to make it work, but I don't want to mess around with it too much on stream. I might need new batteries in this soon too. Nope, just have to tighten the back cover. I do want to keep these somewhat together. So I'm going to put them in my parts tray here. Now there are 2 different variations of the printed part. I'm going to put this where I'm not going to lose track of things. But there's 2 variations of this part. One of them's meant for the 16 tooth idler and the other one's meant for the smooth bearing. This one actually is for the tooth idler. That's what I printed, so I don't know what the exact difference is, but there's probably some variation in the distance there. So pay attention to which part you decide to print, depending on which one you want to do. Or if you're like me, print them both to see how they both do. Okay. That feels pretty good. That one goes over here. apparently I took a tooth dialer out a minute ago, so I've only got one more in the bag here. Oh no, it's still in the old part there. So, Chip, with that in mind, do we need 4 tooth dialers, or do we just need the 2? Huh, that looked weird over on my screen. And actually, with not using the main camera, I can just put this one up a little bit higher for a better shot here, even though I lowered it earlier. Okay, so I think these 2 are ready to go. And the upside to that is we're not going to have to do the heat inserts again. So these are ready. The 2 other go in the motor mount. I figured there was something else I was not thinking about. Okay, yeah, that makes sense. So that's where they go. I'll put this open where people can see it too. So in the CAD, I guess I should make this a bigger. I guess I don't have anything that's just specific for the CAD. But we'll zoom in here a little bit. And you'll see there's a tooth idler that's supposed to go right there. And over this way as well. Now, I think I kind of knew that, but I wasn't sure. I'm just going based off the CAD. So, at certain points, you do need to make sure you do sanity checks throughout your build. Fortunately, I've got Chip here doing it live for me. So before we forget, we're just going to take this other one out so we don't lose track of that. Okay, put those off to the side. And 5x20 hex back in the bag. There we go. Okay, are we ready to start preparing motor mounts? I think we do need some heat inserts on those. Bust this guy back out again. You can see again where you got a little burned right there. And this. So, Chip, I've been meaning to ask, what are these heat inserts for? In the CAD, they are right. Oh, hold on. These ones are for the motor mounted looks, but there's a couple that I wasn't too sure about. Maybe I'm not remembering that right. I think it's these two I'm curious about. Why? Oh yeah, no, these ones right here. These heat inserts. I'm not sure exactly what those are for. Perhaps you can comment on that. I'm gonna put them in anyway, but yeah, I'm not exactly sure what they're supposed to be doing. So for this whole part, we've got 4 inserts plus 1 on the side. Right here. So 1 on the side, 4 on top, and we're just going to do those 2 together before we pull out the other sides of the motor mounts. Heat insert right here. There's not really going to be an easy way to keep this level, but that shouldn't be too big of an issue. And the other 2 slid in so perfect. Nice. That works. Okay. And the 1 on the side. Perfect. You know what? You should definitely put your soldering iron down when you're trying to do other stuff. That's how you burn yourself, melt things, set your house on fire. And ending up sinking those a little bit deep, so I'll be a little more careful. But a little too deep isn't a big deal. Just don't want them sitting above the surface. Okay, so that's it for these two parts. These are the motor mount caps, I think. And these are the motor mount bases. So the base, if we hide it, we can see it looks like there's just the one heat insert from the side. Again, not exactly sure what it's used for. Maybe it's a panel mount? Not sure. But we'll put them in now. That one went a little lopsided, so just trying to fix it. There we go. Look at that. I dumped out just the right number of heat inserts here. Cool. Should be all we need from the soldering iron. Put that away. So with the motor mounts, I do believe you can just build them completely out of the frame, and then once you're done, you can just slide them into position. We were looking at that. I was looking at that with Chip the other day, and I think you can do that. Just slide them in like this. So that's what we're going to be trying to do here. Okay, so these are directional, I believe. We're just going to go ahead and try to put one together the right way of how it looks in the CAD, and then we'll go from there. I think that. Hold on. So, if we're looking at it from this angle, we zoom in here. Looks like that's not the right. Oop, hold on. Let's highlight it. Actually, I'm grabbing the wrong piece. Looking at it like this, that looks right. Yeah, so you see the difference there. They're mirrors of each other. So we're going to grab this piece, which matches the orientation that we're looking at in the CAD. And we're gonna find the matching piece, and then we're gonna keep them together so that they don't get too confusing. With what it looks like, it will go together with this going underneath like that. Oh, perfect. See that? They're gonna fit together, and this semicircle is gonna fit perfectly in there. That is so cool. I never actually realized how these went together until just now. Um, set these together so we know that we've got our sets. Hey Juma, how's it going, man? How's your build coming? And we also need our motor spacers. Let me grab those really quick. Yeah, dude, Juma, if you're contributing, that's donating to Chip's Coffee Fund. That's awesome. He has done so much work with these projects. Throw him a little bit of a donation here and then is definitely warranted. Almost done with cutting your 2020. Heck yeah, that's something I didn't quite have to deal with because I got the sample kit from Fabrico. But how are you doing? Are you just using a miter saw for that, or do you have like a cutoff wheel or anything like a band saw, anything that's a little more precise? I've always been worried about cutting my own extrusion and not quite getting it the right length or not having it square enough. Okay, we're also going to grab one of our motors so that we have it ready. And with this one, got a motor spacer up there. Ooh, let me check and see if I've got those. Okay, 'kay, I have something that looks kind of like it. Hopefully it's the right kind. I need to check how long this is though. 4 millimeters? Ugh. Yeah, that's not going to be this one, I don't think. They're quick enough to print though. I might be able to do that on the fly while we're doing other stuff. Yeah, so these are 2 millimeters. That's, I think, part of the tool head. So I'm just going to start preheating my printer here really quick. Hopefully it's not too noisy. Yeah, dude. You know, kidding. It's always fun to watch the kids come in and just get completely starstruck with the printer and watching it work and watching it being built and coming together. Um, got a few, three kids of my own that just love it as well. Are always asking to help, but it's like, man, I don't even know if I know what I'm doing half the time. So there's only some things that they can help with at this point. All right. So what can we do in the meantime? Let's grab pulley. We know we can put that on, right? So with this one, we can see in the CAD that it's upside down. I guess that's the way I choose to look at it. So it'll go on like that. Let's get our. Is this the right size? Yeah. So loosen the set screws. It goes on like so. This is a D cut motor, D shaft. Some of them are perfectly round, but this has a flat side right here. So it's best if you get one of the set screws to go flat against that surface. Is there a spacer at the bottom of this now? I don't see a spacer, but I almost feel like one should be there. Probably not, though. So we're going to line up the. Let's go just a bit more zoomed in here. We're going to line up one of those set screws with the flat side. We're going to tighten that one just until it touches. Then the other side, this is going on the round part. And if your motor's completely round, that doesn't matter. It'll still work just fine. Then we're going to give it just a tiny bit of torque here. Not too crazy. That's not even like a 16th of a turn. You can always tighten those up later if you need to, but it's really easy to strip them out. We'll see where that lands after we get our spacer in there. Speaking of which, I'm doing the job right now. Motor shaft spacer. That sounds like what we need. Now, it looks like, is it just on the one, or let's check and see if the other side has it too. Yeah, I agree with Chip. I've just used isopropyl alcohol when cleaning it. Seems to do a pretty good job. Um, if if the frame is anodized, then I don't think it's going to hurt the aluminum. In fact, you could probably even use a brake cleaner, brake parts cleaner from an automotive store. It's a little more aggressive, but yeah, I think you can. I think you can use pretty aggressive chemicals on it. But double check that if you're looking into it. So yeah, it looks like we're only using a spacer on one side here, so I really just need to print one of these motor spacers. Um, so we'll go ahead and do that. Although I'm going to print a couple because sometimes my printer likes to let go of the print. And so sometimes one or two fails. Trick you can use with that as well. If I bring this over. Woo. If you add a brim, that can help as well. And we're going to send it. Hope for the best. While we're waiting, you guys want to see something cool that I've been playing with today? I picked up one of these Big Tree Tech Pad 7s. You can actually run this, use it to run Clipper. It has a CM or CB1, which is like Big Tree Tech's version of the CB1 from the Raspberry Pi. And I've been hacking on it a little bit today. When you first fire it up, it has a logo. It comes up, Big Tree Tech and everything. And that's great. That's awesome. But I wanted something a little more custom. I can find a spot to plug this in. Not quite as long of a cord as I was hoping for. And this is not a very power strip friendly plug, as you can see. Looks like it's just a 12 volt, 24 watt. So if All right, you guys hear me now, right? I don't know what's going on, but I have a USB hub that I've been using to plug the camera and the mic in and everything. And sometimes the mic just like doesn't want to work. I don't know what the deal is. So sorry about that, but I don't know where it cut off. But yeah, no, I've been hacking on the Pad 7 for a little bit, and you saw the custom logo that I put on there. Usually it's a Big Tree Tech logo, but wanted something a little more custom. I think it's pretty cool. But yeah, no, you can monitor the print just right from here, and run to Clipper screen, so you can have a couple of different printers going if if that's your preference. But yeah, first time like having an actual touch screen with Clipper screen on it, and I think it's pretty cool. You can literally plug this in, and this can be your Raspberry Pi for your printer too. So they can kind of do a 2-in-1 job. Next thing I need to do is make a battery pack for it, so I can walk around and have it throughout the house without having to find extension cords and plug stuff in like that. Which, is that where the audio cut out? Did it cut out when I was trying to find my extension cord? I bet you that's where it was. Bumped the cable and something went wrong. All right, so we're done with those. Although I am just gonna watch this bed temperature and wait for it to come down a little bit. If you take PETG off of the printer too soon, it warps like crazy, like really bad. Okay, which one did we decide we're working on first? The one with the upside down one, right? I guess we could start working on the other one while we're waiting for the stuff to cool down. But yeah, I have to show you guys this. I thought it was pretty cool. Grab a button set, go to let it together like so. Our other motor. And Chip, does this one go just like flush up against it, or it looks like there's a little gap, but uh, there's no real spacer or anything. So Chip, do you leave yours loose and then go back and adjust it after you've installed everything? So because you want that the teeth to be parallel with the idlers. Just curious what the best thing is to do there. But we'll go ahead and put it on all the same. Again, lining up the set screw with one of the flat sides. And that one was really loose. There we go. You know what? We're not going to tighten any of this at all because we do still have to put this up into, I almost forgot the bearings. This is another Chip specialty. I love it that he does this. Normally, if you're just running a motor like this and you have your pulley out here, the strain that it puts with the belt tension will deform this shaft ever so slightly, and that can deform the belt path, but also can put a little strain on the motor. So Chip likes to put these in play onto where the shaft will set into these. Ooh, that's really tight. Are these the right size? That's really tight. Yeah, it's kind of stuck on there now. Wow. Got it now, but that's extremely tight. I might have to double check these bearings. So the idea is this goes into, I believe this, snaps right in there. So when your motor is doing its work, it's got support from the motor and in that bearing, and it helps keep that shaft nice and straight. Now, why is this so tight? Okay, we'll adjust them later is what he says, but let's check these dimensions here. So we're looking at a 5mm shaft, roughly. I swear it was just measuring 5. I had a little skewed. And these MR115ZZs are kind of the same, but very, very tight tolerance there. Check the other one. Yeah, that's like it's pretty close. Look, does this one go on easier? Man, Chip, were yours this tight? Like where they get kind of stuck on there like that? That's the idea, right? But like if I can get it on but uh not off. I wonder if it's because of this D cut, if it's just like a little. Yeah, I just don't want to put him in and then not be able to get him back out. But yeah, I think you're right. As long as we can get him in, I didn't push too hard to get it in there because I still want to be able to get it out, of course. But yeah, I've used ones like this before, and I swear that they didn't quite have that much resistance. Looking at our part now. You know, Pet G first layer, I had some hard times with it getting started, but you can see not too bad now. I don't know what your guys' process is, but a little scraper like this helps to keep your bed from getting too scraped up from metal stuff, and it stops the oils from your fingers from getting all over, you know, on the print surface. So with this, makes it easy to pop these things off without too much hassle. I see printer kits coming with metal scrapers. I'm like, ah, why would you do that to your poor bed? Yeah, I think the D cut like this. I didn't try measuring on the D cut. I wonder if that's what's going on here. Yeah, so when I measure from the D cut edge, it's a little bit higher. And if we're pushing into this bearing and it's forcing it outwards, then it's going to put pressure on the balls inside, on the ball bearings, and that'll cause it to fail faster. So yeah, Chip, yeah, Chip, I think that's a good idea. I might run a file over these to file them down a little bit, and this is very interesting. I've never seen that. I'm trying to get like a really close up, good view of what's going on there, and I don't know. if you can see it on camera, but it almost seems like it does protrude out just a tiny bit from the circle. Yeah, there's no way that's going to show up on camera. Um, so yeah, it's like if you make a circle and then you run your cutting tool down to make a flat surface, you always have a little bit of a burr or metal that gets pushed to the side instead of removed. And I think that's what's going on here. So let's pull out our handy dandy file, put it to work. I'm going to start with maybe like one lick per side. Oh man, come on. Because if I overdo it, then it's not going to be very usable. And we just kind of have to work with the top here, so we don't have to go all the way down the shaft. All right, let's see what that did for us. Just ever so slightly feels like it might have chamfered it enough, but yeah, kind of gets stuck in there. Nice thing about these motors is that they're custom, so we can order these with D shaft, non-D shaft, different lengths if we need to. So this shouldn't have to be something. This shouldn't be something you have to do on your builds. Also, kind of run it along the top because these corners might be the thing that's causing the biggest issue. Make sure it's nice and clean. Still not quite. Okay, you can probably see a little bit, but we've got just a small amount of chamfering on there. I might have to take a little more off in the center, but let's see what that does for us. Okay, it definitely feels easier, but it gets stuck again. This is kind of a hard angle to get that part. I know I'm using my file the wrong way because it's not supposed to be used in both directions like this, but kind of limited on my options. It wants to, but it's just so close to not quite wanting to go all the way on there. I've been really gentle with it up until now, but I think at this point, like, let's just get it to work. Again, this part is just kind of for support, so this isn't going to affect the the motor at all, or the pulley at all. This is an LDO. It's actually the ones they use in the Mercury Zero G. You can tell by their logo there. But it's a Honey Badger. Is it LDO? I think it's like Honey Badger um, custom LDO motors, but I could be wrong in that. But they're Honey Badger ones that are used for the Zero G. When we do the full kit, we'll get our own logo and specs on there, of course. Still fighting me. Not something I was planning to do today, but this is what beta testing's for, guys. Okay, if that doesn't work, that's... Yeah, so I've got it kind of chamfered near the top, and that's working okay, but it's got to kind of go all the way down to be effective. So we're just going to go at it. Trying to just keep it to the top, but quick and dirty job like this don't always get perfect results. Oh man, yeah. I can push it on there, but it's making sad noises as I do it. I think we just need a bit more on this side. It's crazy. I wonder if we've got too much dust in this one now. Yeah, because this one goes in a lot easier, so, and it comes off a lot easier. I may have actually deformed this one from trying to force it on too much, but let me see if I can clean it out really quick. Just gonna run, a microfiber cloth in there, so if there's any tiny degree or particles that are causing it to stick, this will help clean that up. Yeah, I'd say that's acceptable. It still feels like there's a little tension, but it still spins freely. But yeah, that's definitely something that we'll get taken care of in production for you guys. One sec. Okay, and grabbing our next motor here. Get it both out of the way while we're at it. Pop our bearing back in there. I'm gonna use this cloth to set down so that it doesn't quite make as much noise. By the way, guys, I'm doing this because it's a beta kit. I would never do this on motors that I paid for unless I was really in a bind. Um, if you get the wrong motors, you know, try to get a replacement or get something that's going to work better. Because as soon as you take a file to it, if you send this back under warranty or for any other reason, no one else is going to want this. So I'm doing this on my own at my own discretion, but don't ever do this on motors you paid for. Unless you just don't care about wasting your money if it goes wrong. Because if I overfile this, the motor's basically, or if I file it in the wrong spots, it's going to be basically worthless. So maybe I should have just done this all off screen, but or you know, I could use different motors too. I might be able to find something else around here that I've got that would work. Hardest part is keeping it locked in place while I'm working on it. It does feel like I'm having to sand down a lot more than I expected. So it's got to just be like the shape of it in certain spots that are not seeing right away. Let's see how close we are. Okay, that's pretty good. We can still put it on, get it flush, and take it off without too much hassle. So we're rolling with that. That is jank as hell, But if it works for now, then who really cares? Oh, I see what happened here. So I filed down while I was filing. I was just kind of filing this rounded spot when I should have been filing more uh, on the actual edge. So, yep, pay attention to that. All right, back to where we were. I think I got these mixed up. Yep. So, with the part we're working on, checking our CAD here. You can build it, pick which direction is going to be the front to you. To me, this is how I prefer to look at it. So this is what we're looking at. See how that matches up with the CAD? Whoop. Bearing fell out. So I think it looks like we probably want to install the motor first. Start getting that in place. Don't tighten it all the way. Then install our bearing stacks. I think that's going to be the way to do this. So before we do that, we need to check which screw lengths we need. M3x40. M3x40. Are they all M3x40? Okay. I wasn't sure if, yeah, no, they are. I was getting mixed up in that some have to go through more of the plastic, but they're all the same distance. 3x40, 10 pieces. My remote software just crashed, but it looks like the stream's still good. Any better? There we go. Okay, so I think what was happening is if it comes unplugged for just a moment, it was switching to some other microphone for some reason. So thanks for calling me out on that. Hopefully we don't have that issue again. Thing, I'm not sure where the audio cut out, but I was telling everyone that we forgot a part. We had to double check what we're doing. And it looks like this goes over the top. Hold on. Wrong one. They are directional. And this is going to... So I guess this is kind of technically a motor spacer. I don't know if that's what it's called in the CAD. Yeah, motor mounter spacer. Man, I'm so glad that we actually have someone here live that can tell us when the sound is cut out. If I was just streaming to myself, I'd have a whole video with no audio. So this should go in place like so. So you've got, there's a flat side and a side with these, right here, with these lips, these spacers on the spacers. I'm not sure what else to call them. Those should go up, face upwards, and when we put it together, it's like that. And again, our electrical connection is over here facing the heat insert. Uh-oh. If I start forgetting my words like that, it's going to be time to call it a day before I start making more mistakes. So, you can see I had the bearing on the shaft already, and it's not quite all the way in there. I also didn't put the stinking pulley on, so back it out. I remember the pulley last time, but then forgot the spacer. I'll get it right one of these times. Oh no, where'd it go? There we go. So this pulley goes up like so. We're gonna leave it loose-ish for now. For now. Oh man, my voice is cutting out. My kids have been coughing all week, and I haven't caught whatever they had, but my voice has been extra hoarse. So like maybe I've got it, and it's just not quite as severe as what they got. All right, thinking about this the right way again. Those bearings were not that loose when I first put them in there, but I think I've played around with them too much. They've worked themselves looser as we go. Oh, hold on. That's upside down. There we go. Okay. Sanity check. We have our motor mounter spacer. We have our pulley. We have our bearing. I think we're good now. We can do it from the side so that we don't drop the bearing again. I'd prefer if that bearing was a little tighter in there, but if it's, you know, if you guys run into the same thing, I don't think that's a reason to, you know, reprint everything. Just makes it a little harder during this part. Dude, that is so loose now. It was not that loose before. Okay, we're just going to insert it on the shaft like we did originally. just a little bit, and that should push it into place. Okay, so we're on there. We're loose, but we're together. That's what counts. Now, we get to build some more bearing stacks. I see what you're saying. That would make sense, wouldn't it, Chip? And if I take these out, I think that's where I kind of screwed myself over by trying to get a little eager on the screws. But I think you're right, Chip. We take all this out. Come on. Set it upside down. Now with no screws in there, we can actually work with it like this. Brilliant. Set this in like so. Now, actually, we can put these ones through because they should sit flush, right? Oh, they don't quite sit flush, do they? That's still okay. That doesn't really matter. What I mean is that they don't sit flush against this part, so it doesn't sit flat. But that's not too big of a deal. In fact, you can just, if you have a board like I do, you can run it off the side so that they're a little bit off like so. Okay, so these bearing stacks I think are going to be the same as last time. Bearing, spacer, right? Bearing, spacer, bearing. Spacer, bearing, spacer. We're going to call these ones spacer and the thin ones washers. Just for the sake of keeping the terminology as simple as possible. So we bring out our washers. Actually, these washers, not these guys. Got our bearings that we took out from the other motor mount. Not the motor mount, the Y carrier when we put our tooth idlers in. And we will want to put these in place too, so we can build it on the screw itself. There's no transfer necessary. These ones don't slide in quite as easy. They might be a slightly smaller hole, so we're going to screw them in. Oh, there they go. Yeah, that's interesting. There they go. Sometimes they want to go, sometimes they don't. All right. So we go flat bearing, you know, bearing with the flat side going down, the large flat side. Then washer. Where's my tweezers? That'll make this job a little easier. Push those down. Let's get a better close up with this. Okay, so we've got washers on both of those. My bag of bearings is right here. Let's line this up with the, yeah, with the tape, so I can tell when I've got something in focus. There we go. So then we do another bearing. Printed spacer. Well, I'm gonna have to print more of these spacers too. I only had 4. Well, let me fire up my handy dandy pad. This is actually super helpful for the stream, so I can start prints and do stuff right from here. After our spacer, we do another bearing. Thanks for the advice on this, Chip. Oh yeah, the 16 tooth idler. That's gonna go, okay, based on our orientation. I'm looking at, we should definitely update that in the CAD, Chip, since that's gonna be the reference point. So it looks like on this, it's going to go on this bottom one, I believe, if I'm not mistaken. If I'm looking at the right one. Yeah, I'm pretty sure this stack right here is what needs to be the toothed idler. So actually, I'm going to just take this off so we don't have to redo the bearing stack. With the washer, transfer it over there. But the washers really quick for the spacers. Oh, oops, that was the wrong button. It's going to print a million of these things. Yeah, just stop what you're doing there, Prusa. Okay, thank you. Set number of instances, 4. And that looks good. Good. Yeah, so I'm pretty sure this is where the 16 tooth idler goes. If I'm wrong, we can adjust it later. Other nice thing about printing these bearings with brims is they all just kind of stay together and you can keep them together instead of losing these little pieces like I've been doing. I guess there's a better shot. I'm pretty sure I printed those before, but I don't have them anymore, apparently. Now, I think we need this off of here. Come on now. Transfer it over there. Then, bearing washer. Bearing, I believe. I believe that's right. Or is it... This is upside down. Yeah, actually, no, I think we had it right before. Where we do bearing stack first. I was thinking like, oh, the idler goes on the bottom, but not really. It goes on the top because we have it upside down. Oh, I thought there was a washer there. Nope, we're good. Then... Am I the only one that struggles with that? Like looking at something in CAD and then looking at it in real life and just getting so lost about like, is it upside down? Is it rotated 90 degrees? Like, I do not have that spatial reasoning to trust myself to just wing it on that type of situation. That's why I try to get it like 1-to-1, as even as possible in the CAD to match what I'm looking at in real life. Because if it's not exactly the same, then my brain just like implodes. Not sure if that's a skill that just some people have or don't, or if it's just something that I'm a little deficient in, or maybe I just haven't worked enough in CAD and stuff like that to develop that skill. I don't know if it's a skill or a natural talent that just some people have. Okay, that's on there. Okay, I think we're good. Okay, so now we can put our motor in. We can flip it like this. Chip says he's going to check on that for me. Double check. That would be awesome. Mm, I think it does go back over here, but I keep changing my mind. I don't know if you can get a good view of what I'm looking at here, Chip, but that's what I'm looking at, which is basically this assembly upside down. Okay, yeah, so I think you're right. So if we have it like so, you're just like I was saying a second ago. Finally, I think this is what you're talking about. Whoop. So goes right here. There's our logo. And I'm just gonna wait for a confirmation from Chip, make sure that is in fact right. Cool. All right, we're golden. Thank you so much, Chip. Put the spacer in before the motor. Um, this one doesn't use a spacer, or you're talking about this spacer, I think. That actually makes more sense. This this part makes a little, or it's a little bit easier to tell where it goes because the two ridges right here, this part, those are going to go on the the parts with the bearing stacks. Assuming we get this right, and then it should, it's like it's supposed to line up with this edge. So that should be pretty easy to tell if you've got the right spacer. Just checking my first layer. Looks like it's okay. So let me just pull that up on this camera. The camera is nice, but I can't really get a good picture of the layer itself on the first layer. So I have to check that manually usually. I should get a nozzle cam for that. That'd be pretty cool. Okay. Onto this. I'm flipping it around because I'm using that heat set as a reference point. I know that my wire connection points that way. So again, trying to make it easy on myself, trying to give myself as few opportunities as possible to make the mistake. Then we can just drop the whole thing down on top. Once those are in, we can turn it on its side. Like once they're kind of sitting in the threads a little bit, and we can get started. Get all four holes started before you tighten it all the way. And just get them semi-tight. Cool. Now with these, you don't want to over tighten the bearing stacks. You want to be very careful with that. So I'd say, maybe tighten these first. But if you tighten it and you start to feel the part deform, or you start to feel too much pressure, you're doing it wrong. So like even with that little tightening right there, I started feeling this idler was either binding a little bit or was pushed down a little too far. And so I'm actually feeling how smooth these are as I tighten. And if it gets too bad, back it off. Wow, yeah, this starts to bind with very little force applied, so do be careful. This one I can tighten a little bit more and it doesn't feel like it affects it quite as much. I don't know if that's just because this actually, let me try to tighten. No, the more I tighten, I think this spacer might be the spacer in the middle there. Grab the tweezers. Might be pushing against the outside part of the idler here. It's supposed to just sit on the center part of the bearing. Let me grab another one to show you what I'm talking about. And that could just be a printer dimension thing for me when I printed the spacers. But basically, you want your spacer to just touch. Ooh, which way's up? To just touch this part, the center brighter part. If it's touching the outside of this stuff, then it's going to cause that friction that I talked about. That's no good. So it's probably just a printer dimension thing on my part. But it's just ever so slightly, I think, touching that. So what we're going to do is we're just going to leave this loose enough to where it's not pressing into that. And that'll work for now. Should be easy enough to change out later if we print a bearing with a better tolerance there. So that's what we got for now. Changing things up here a little bit. There we go. All right, let's take a look at some spacers. Oh, hot, 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 hot. I'm printing this with a 90 Celsius bed, so it's quite hot when it comes off. Okay. Once I start to see like the skirt and even parts of the brim start to discolor and come off, then even if I'm feeling impatient, then I feel like I can go for it. But if it feels like the plastic is peeling off, then it's probably not ready yet. Yep, so let's just wait. Now Chip says we should be able to use the belt in there to help position the pulley. So let's give that a shot. A bit of belt. Actually, no, this is the longer piece. Not sure where I set the other part, but this should work for now. I might just settle for doing this after if I can't get this around the pulley easily right now. Let's see. ProosaXY belt pathing is so cool, but I always struggle to make sense of it just looking at it without the actual reference in front of me. We're going to use some tweezers here to kind of get it all pushed through. Okay, that wasn't too bad. I do want to cut this belt a little bit shorter though. So I don't have to feed the whole thing through. But this is going to be the basic idea of the ProosaXY. It goes around the pulley, but then gets sent around the smooth idlers on the smooth parts. So might be able to push through on this side. You just find the right combination of tweezers and tools. That's gonna be the tricky part. But I think even just with around one should help us align things fairly well. And then again, we'll come back and adjust later if we need to. You can actually use the belt to pull and rotate so that the set screw, see how the set screw, I can't get to it right now. If I pull it, I can now. Tighten that one. This is actually the one on the D shaft, so I should have tightened this one first, but we're just going to leave them kind of semi-loose for now because I have a feeling I'm going to be coming back to do some work on this one. Should be ready to pop off now. And those are on there good. My first layer might have been just, or my touch Z offset might have been just a touch too low. There we go. Okay, I'm trying to decide if I want to do this next one or if this is going to be better to save for tomorrow. Let's get it going. We can do it. We can get it done tonight. Just did the other one, so the second one's always goes a lot faster, right? Okay. Now for this guy, upside down, we're going to be putting the idler on. Through where the front is. So I think there. I think that's the one. Now that I have my bearings on this a little bit better, you know, this is the front that we're coming from. And if we put it on the bottom, that equals the top because we're flipping it over. We're working on it upside down right now. So unless I'm wrong, Chip, I'm just rolling forward with this. We also have our motor spacers to use now. Nice. That's a lot easier to recognize this right spot once you've done one of them already. So thanks for the support as always, Chip. Just want to get this set in so it doesn't rotate off of that flat spot. Not tightening anything really, just making sure it's not going to rotate around and have the set screw where it's just rotating around without, you know, having the set screw line up. So now we can take one of these. This is always satisfying. Don't want to mess it up though. Better grip if I get the right tweezers in there. Man, that is in there. I think I already kind of deformed that one. All right, well, let's give it a relief cut on this side. Sometimes with these, it's just all about getting it started. Then it'll peel right off. Yeah, I think my first layer height was a little low. That it was just perfect and bonded everything super well. You have to clean it up a little bit. Go ahead and do so. I don't think this one is too critical. If it has a little bit off to the sides, I think that'll be fine. But I don't like to leave any burrs when possible. Cool. And just in case I did have some burrs, I'm gonna put it down like so. Ooh, yeah. No, even that's a squishy, tight fit. But again, it's just a spacer. That's what it's there for. Right? Motor shaft spacer. Again, this one's easier. Oh, no, wait, we need to do our bearing stack. What am I thinking? Told you guys, it's almost time for bed. Oh, but I beat my game last night. Final Fantasy VII Rebirth. One hell of an ending. I won't say anything else about it in case you're planning to play it. Looking forward to part 3 when it comes out. And I mean, judging by how long it took for part 2 to come out, it'll probably be another 4 years, which sounds crazy, but that's kind of how it goes with these games. But part 3 will be the final one, just like disc 3 of the original. So it's going to be the last one of this series. So these are our bearing spacers, not the motor shaft spacers that we already put on there. Had to print a few more live because we didn't have enough. Holy hell. Dude, Pet G is so much more bouncy and springy. I have no idea where that went. Like, all plastic is going to be a little bouncy and springy, but I swear Pet G ones just spring loaded. All right, let's grab another one because I'm not going to spend all day looking for that. Sometimes you can get your side cutters in there and kind of pry the brim off. I was trying to do that earlier. I wasn't having too much luck instead of cutting it off, but this looks like maybe it's going to work. So close. I think that's relatively good. Now this is the part that was touching against the bearing and causing that other one to rub, so I'm just trying to clean up as much as I can from it. Okay, let's go with that. It's a little tight, but that's okay. It's usually easier if you can get equal force on it. Come on, Meow. There we go. Bearing. Washer. Maybe. Go. Bearing. Bearing. Washer. Bearing. Let's grab another spacer. Oh, that was so much cleaner than the last ones. Benefit of prying it off is that you usually get most of that elephant's foot or brim with it, so it's not sticking out anymore. Whereas if you cut it, you kind of have to go around and do your best to cut the sides off, but it's usually not as clean doing it this way. So your side cutters are cutting in a straight line, but with a circle, you're only getting like a point of contact when you're cutting. Okay, let's try that. Yeah, I've been playing around with my XY offset. It sounds like, or it feels like it's a little undersized right now, but no big deal. Okay, last stack, bearing. washer, bearing, motor mount spacer, man, this went way too easy. I feel like I'm missing something. That's it though, right? Same thing. This goes, yep, our motor shaft bearing is down there too. Electrical connection goes towards this little heat insert. Set it on there. Get a couple started. We've still got quite a gap here, so we've got a bit more that we can put on this. Okay, that feels a lot better than the last one, and I was able to get a little more torque on there, and it still feels like it's moving freely. There's no friction there. This feels the same. Back here feels good. But we're going to tighten until we feel... No, that feels good, and I feel like that's the right amount of tightness there. You can feel or hear it squeaking a little bit. That's probably a sign that it's done. Oh, yep. So that squeak was what took it from being moving freely to too much. So back it off just a little bit. Then one little bit more. Perfect. I like it. Okay, so there we have it. We have 2 complete motor mounts. Let's go ahead and see if we can put them on the frame and call it a day. Hey, are we still live? My YouTube thing right here is telling me that it's not connected to the stream. Anyway, hope we're live. If not, I'm at least recording to video so we can upload this later. That warning went away, so I guess we're still good. Also noticed yesterday, come back out here. Actually, I noticed today, but on the last stream, zoom this out more. No, that's as zoomed out as we get. On the last stream, I had actually loosened this profile by accident, so we might not be square here anymore. Hopefully we're still good. I tightened it back up, but let me grab a machine square, make sure we're still good there. Actually, that doesn't... Does that affect It does, right? It does affect the motor. Yeah, to a degree. But we'll install the motors. If it's not square, I'll true it up off stream, and that'll be fine. Okay, now the easiest way to tell which one goes where is the electrical connection will be facing the outside of the printer. So in this case, it's going to go in. Hold up. Oh, because this goes on this side. Let's turn what we can without knocking stuff over. I think. Nice. I like that. That felt so good. Let's raise that just a little bit. And get more of a angle maybe. Yeah, that's probably a good angle. This goes right in here, and that just slides right into place. Feels very solid even before I've tightened anything. So we know we need an insert, a roll-in T-nut here, and here, and here. Let's grab those. And if you stand up and look at where they're going to go, slide them into position. I know you can't see, but you should be able to slide it into where you see down through the hole. I'm looking straight down through here, and I can see that it's perfectly lined up there. Same thing from the side here. This one you might be able to see a little bit better. Oh, I've got that in the wrong way. I don't want it like that. I'm putting the hole in closer so they don't have to push in quite as far to get it lined up. And no way you're going to be able to see on camera, but nice. That actually does stay in place. But maybe there's a chance you can see it on camera. Maybe there's a chance. Digital zoom looks awful, but you get the idea. Yep, just like that. There's a good shot of how you can line those up and quit the guesswork. Try doing that with the T-nut. We've got one more to do on the side. This one you probably can't get a good shot or a good view inside, but you should have a good idea of where it lines up still. So because of that, I'd recommend trying to get this screw started. Oh, let's zoom back out. Oop, we just lost the feed. Probably put something on my iPhone. Yep, I opened up the camera. Okay, should be back. Why is it not back? There we go. So I'm working on the one that goes behind this profile. There's a screw that goes in right here. I should have that zoomed out way more. Also, oh my goodness, I think I did it again. Actually, I think what it's doing is it's locking my phone. The camera mount that I'm using is hitting the button. So this one back here, there's a screw that goes in right here. And so you won't be able to see this insert quite as well. So that's why I'd recommend getting this one started first, because our other ones are lined up perfectly where they need to be. Still, let's push it into about where it looks like it's right. Then we're going to check the CAD. This guy is an M5x20. Got some of those right here. Don't forget your washer. This, I think you actually do have to take it out and get it started here. And then you can slide it back into position. And this is going to be hard to get on camera and also for me to see what I'm doing. So I'll show you what I'm going to do, and I'm going to do it probably where you can't see quite as well. So I'm going to be getting it into place there. And that's going to be tricky. Once it sets in place, I'm hoping I can get a wrench in there, even if it's one of the smaller ones. Let me set up another view. There we go. So maybe you can have a better shot of what's going on. Okay, the trick to this let me know if you have any advice on this chip. Almost be nice if there was just a wrench hole right through this side that we could go through. In the end, I mean, I'm not opposed to just drilling one and doing that right here. Maybe I've got a wrench that'll fit in the side there. Hoping once it got sat in the hole that it would be a little easier to work with, but I don't think that's going to be the case because it's ready to start threading. I mean, I can maybe get a finger in there to start going, but that is tough. Yeah, you can see even, well, I guess you can't see, but even with this wrench, I can take this, like that. Even with this wrench, it's a little bit smaller, it's still Like, doesn't even clear the printed part. So that's gonna be a little tough. Okay, so you take this back extrusion off when you did that. Okay, I'm thinking that what I'm gonna end up doing is drilling a hole. Um, whoops, back here. I think I'm gonna end up drilling a hole right here, just a wrench hole, kind of like this, just to move down a little bit, and that'll make it so much easier to install that. Chip, I don't know what your thoughts are on just getting that machined in from the parts kit, or if there's a design modification or just even a different tool that we want to use. Um, Another option is if you have one of these, uh, if you got some of these cheap ones that just came with another printer, we could actually just hacksaw this off. You guys know I'm not afraid to use a hacksaw. So it's just a barely, I don't know what you want to call it, a short throw wrench. But that is the alternative if you don't feel like drilling the extrusion out. But that's a decision I'm going to make after a good night's sleep instead of starting to cut and drill and do stuff that's not reversible. We already filed down some motor shafts today. So I think we're going to call it there. Sorry we didn't quite get to what I was hoping to get to with the Y gantry, but we'll get there. I promise. Aside from that, yeah, I'll see if we can get this going again tomorrow. But aside from that, hope you guys all have a wonderful